Hello everyone, and we are at the end of 8.1 talking about even more examples of solids of revolutions with disks and washers, and I'll vary it up from some of the last examples you've seen in these videos. So quick recap, as always, this one will be even quicker than the past one. We have the volume of disks, which is just based off a cylinder, which is going to be the volume from pi r squared dx, or of course if going up and down, pi r squared dy. And then we have the volume of washers, which has a hole in them. I'll draw them both ways. So the dx are going to be vertical cylinders, dy it would be your horizontal cylinders. And let's see here. So your volume, if it ends up creating this shape, you'd be rotating about the y-axis, like I am there. This is about the x-axis. And you'll get their volume from down to up of pi outer radius squared minus your inner radius squared dy. Or if you rotate about the x-axis, you'll get washers that look like this. And your volume will then be left to right of pi outer radius squared minus your inner radius squared with respect to x. Okay, and that's it. And then we've seen videos where we just have to account for the radius. Just be careful. Note, careful finding your radii. Okay, but as always, draw your pictures. Draw a cross section. And label carefully. And that's where it's usually where the biggest mistakes happen, is labeling carefully, where you have to label your radii and your height / thickness of those discs or washers. And from there, you can calculate the volume. Okay. So let's look at an example. Let's do the region bounded by y equals root x, and I'm going to see here. So y equals root x would be 1, 1, 2, 3, 4, up 2. Okay. And let's do the region. What if we do that one might be kind of neat. Oh, no. I don't want to make it too much. Okay, let's just keep it simple. Let's do y equals 1. We'll bound it this way. There's y equals 1. And then we'll do x is equal to 1 to 4. So you get a nice bound here. So there's our region right there that we're looking at that's bounded by those curves. Okay. And in the first example I want to do is let's rotate. We'll do 2 of them here about the y-axis. That's my little variance from the last videos, is we'll rotate about the y-axis instead here. Okay, so that shape is coming towards us, back to the paper, then behind the paper back to where it started. So what you end up getting here is a kind of interesting donut where it's kind of like slanted inwards. You can imagine that. So it's like a donut that would look something like this as it comes around. Wow, that's an awful picture in retrospect. My head visualizes it. I don't know if you see it, but it's like a donut where it's all funneled inwards because of the curve there as it forms around. So it's a funneled inwards donut, almost, is that shape we'd be creating. Okay. So let's see what our cross section would be. So if we got to rotate this way, we have a rectangle. It would fill up the space. Okay. And if we rotate it about, there's your inner radius squared going to, and then it'd be going behind the paper. There's your outer radius squared coming through, coming behind. And then down here is your thickness. Come around like so. Okay. So drawing it out down here so you can visualize it a little bit better. You get a washer that looks like this. It's the cross section here. So again, this right here is your 3D shape that gets created. That's the 3D shape. This is just a cross section, which is a washer here. Okay, so let's label it. So the thickness of this washer is going to be dy, that very small change in y as we make them infinitesimally small. Now your outer radius from here to here, your outer radius is equal to, well, what's the distance from this curve, which is 4, and here's your center? Well, that's a distance of just 4, so that's simple enough. Your inner radius from the inside of the curve to that, which is from your square down to here, well, that's the curve y equals root x at any moment. So it would be your inner radius is typically root x to that center, which is 0 there. But root x, we need it in terms of y because we're going to be taking the integral with respect to y and looking at the changes as they fill up that space vertically. So we're going to have to make that, let's see here, y equals root x, which would imply x is equal to y squared. So your radius here is going to be y squared. Okay, so plugging it all in, we'll have volume is going to equal the integral from 1 up to 2, I think is where I did it, because at 4, this is y equals 1, and at this point we're at y equals 2 on the curve, because I did that as the 0.42 purposefully. So volume from 1 to 2, filling up the space with all these cross sections as we cut it horizontally here. And your outer, it's going to be pi times your outer radius squared, which is 4, minus your inner radius squared, which is y squared, times the thickness, which is dy. Okay, and we'll do this one out by hand really quick. So we end up getting pi times the integral from 1 to 2 of 16 minus y to the 4th dy, which is going to give us pi, and then the antiderivative of that function is 16y minus y to the 5th over 5, evaluating from 1 to 2. And plugging that all in, we'll get pi times 32 minus 2 to the 5th. Well, what's 2 to the 5th? 2 to the 5th is 32. So we get 32 minus 32 fifths minus 16 minus 1/5. Simplifying this a little bit, we'll get pi. 32 minus 16 is 16. 32 fifths plus 1/5 would be minus 31 fifths. Timesing by 5 to make that common denominator. 16 times 5, I believe, is 80. So then we get pi 80 fifths minus 31 fifths, which would give us our final answer in exact form of 59 fifths pi units cubed. That would be the volume there. Okay. Oh, 49, sorry. So I checked on the calc, I was like 59. It's not right. Add 9, you get 40. Yeah, 49. Okay. So there you go. There's one problem. Now let's do the same thing, one more, but let's rotate somewhere even differently. Okay. So let's rotate about, I'll do it down here, B. And it can be any line, but I do want to keep it rotating over a vertical line. So let's rotate about the line x equals, rotate about x equals, say, 1. Let's change it up a little bit. Okay. So if we have our picture, and the bounds were y equals root x, so 1, 1, 1, 2, 3, 4, up 2. We had root x, y equals 1, give it a bottom area, x equals 4, 1, 2, 3, 4, like so. And then we're going to rotate about x equals 1 now. we're going to rotate about this line. Okay, so let's piece it all together and see what we end up creating. So if we make our cross sections, so we fill our space with a rectangle there. And we're going to rotate about this line. So let's see, here's your inner radius going around, and then it would be behind the paper. Your outer radius going around and behind the paper, and then you have a thickness there. It would look something like so. Okay. So if I draw this out, what we end up getting are cross sections that are washers. Okay. Where the thickness is going to be an infinitesimally small change in y, very small number. And then let's see, now we have to do kind of the tricky part of finding the radii. So your outer radius, I'll do it down here. What's your outer radius? Well, let's see. If we look at our drawing, there's your center C. Well, what we know is that the distance from 4 to the curve is that would be the curve. That would be a distance of, well, sorry, why am I saying to the curve? We're not going to the curve. The distance from 4 to this, which is 1, is just the distance of 3. All right, that distance from, that's 4, that's x equals 1, so the distance there would be 3. Inner radius, outer radius is 3. Now what's the inner radius there? What's the distance from your inside to this curve? What's that distance? Well, you notice that the distance changes along all those moments. Okay, so the distance from, say, the curve, and this was, again, in terms of y, it was y squared. So the distance from y squared to the center at the beginning was a distance of 0. And then as you kept going, the distance from, say, here to here would be y squared. Well, careful. This is where it gets hard. The very first thing I said there was kind of wrong. All right, so what's y squared? Y squared, if I think about this, draw it out down here. Well, that's the distance to 0 at every moment, right? That would be a distance of y squared that we would account for. But notice that we're not rotating to 0, we're rotating about 1. So we calculate y squared, which is the distance from the curve all the way to 0, but then we have to go backwards 1 and subtract 1. So if I do it out right here, so your inner radius, what I was saying here is the curve y squared would actually go farther back. That right there is y squared because it's from the curve to 0. But then we don't want y squared because that's more than the inner radius there. So we have to subtract off this amount, which is a distance of 1. So we subtract off that amount, which creates an inner radius of y squared minus 1. And that's where you can see it gets a little bit tricky with your radius, your outer and inner radius here. Okay. So a bit tricky there. Hopefully you followed me on how I got that. And if I have scratch paper somewhere, I'll use the last one. All right, so let's use this to calculate the volume. So your volume of this is going to be from 1 to 2, as we fill up this space with cross sections horizontally, of pi times your outer radius squared, which was 3 squared, minus your inner radius squared, and your inner radius squared there was y squared minus 1, and all of that squared, and then with a thickness of dy. Okay. Now, we'll do it out by hand just to help you understand this, because it's easy to use a calculator, but it's hard to do it by hand, but you need practice. I mean, a lot of it just comes with practice. So you get 9, and then let's multiply this out. We get 9 minus y to the 4th minus y squared minus 2y squared plus 1, and all that dy, which would end up making 9 minus y to the 4th plus 2y squared minus 1. So putting that together, we have pi. And hopefully I'm not making a mistake. I'm going kind of quick through this. We would have negative y to the fourth plus 2y squared plus 8 dy. That's a little bit easier to find an antiderivative of. So to calculate this, we'll get pi times negative y to the fifth over 5 minus 2y to the third over 3 plus 8y, evaluating from 1 to 2. And plugging that all in, we're going to get volume is pi times, let's see here, negative 2 to the fifth over 5 minus 2 times 2 to the third over 3 plus 8 times 2 minus negative 1 to the fifth over 5 minus 2 times 1 to the third over 3 plus 8 times 1. And as much as I just want to use a calculator, we'll keep going by hand. Negative 2 to the fifth. Is it negative y? Or no, careful. So it's negative and then 2 to the fifth, because I noticed up here it was negative and then the y is to the fourth. So make sure we're careful of that. So it's not the function, it's not y bit, it's negative outside of it. So 2 to the fifth is 32, I believe. Let me check on my calculator. Yeah, 32. So we get negative 32 fifths. And then this one would make 8 times 2 is 16, minus 16 thirds, plus 16, minus, well, let's see, keep it minus for now. That would make negative 1/5. That would make minus 2 thirds, plus 8. Combining all of that, we get pi times negative 32 fifths. That would make that plus a fifth. So that would make negative 31 fifths. 16 thirds, and that was a minus. Minus would make that a plus. So negative 16 thirds plus 2 thirds would be negative 14 thirds. And then 16 minus 8 is 8. Okay. Keep going. Common denominators there would be, let's see here, negative 31, or just 31 times 3. Negative 93 over 15, 14 times 5 would make minus 70 over 15, plus 120 over 15. So you're going to get here negative 93 minus 70 plus 120. Negative 43. Why are we getting a negative? I made a mistake somewhere in this math. That's a negative volume, and I think you can have a negative volume. Where was my mistake? Maybe you caught it already and you're like, this is hard to watch, Mr. Hein, but let's see. Pi, your outer radius was 3, and the radius was y squared minus 1. That makes y to the fourth. Let me check. Y squared minus 1. I make y to the fourth minus 2y squared plus 1. All that negative would make that negative, plus minus negative y to the fourth plus 2y squared plus 8. That's good. Antiderivative there would be negative y to the fifth over 5. This was a plus. I don't know where that became a minus from. So that's addition. Let's see, then that's addition, then that's addition. That would make that subtraction. And then here we'd have 16 thirds minus a negative, so that'd be plus 2 thirds, so you end up getting plus 18 thirds there. So 18 times 5 is 90, so that should be plus a positive 90 there. So then what we end up getting isn't this answer. You get pi times 117 over 15 and units cubed. Okay. And there's the volume of that donut. So hopefully if I put it all on the screen, you can see kind of how we work through it. The radius, again, is the trickiest part. In this case, I showed a video where not only are we rotating this way, but you had to go back one because your radius was a little bit smaller, okay? So I hope that helps. If you do have questions, make sure you stop by office hours and ask there. But that's it for 8.1. And the next thing is one more set of volume. with a different method, but if you're getting this, you're on the right track. All right, good luck. Bye-bye.